Dear viewers, you are my greatest inspiration. You have supported me all these years. Your kind words of appreciation motivate me to keep making more videos. On my online video tutorial channel, knowledge-seeking enthusiasts with further interest will find a wide choice of variety of immensely elaborate video lesson series. Prior to watching this video, viewers are advised to watch my video lessons on lunar nodes, lunar standstill, as well as Earth's third motion. Please note that illustrations are not to scale, and certain illustrations have been exaggerated for the purpose of comprehensible clarification. Here you see a comparative illustration of the axial tilts of the Earth and the Moon. Earth's axis is indicated by sky blue dashed line. The direction of the Earth's equatorial plane is indicated by sky blue dotted line. The direction of the Earth's ecliptic plane is indicated by bright yellow dotted line. As we already know, Earth's equatorial plane and ecliptic plane are at an angle of 23.5 degrees with each other. The direction of the Moon's orbital plane is indicated by white dotted line, which is at roughly 5.2 degree angle with respect to Earth's ecliptic plane. Here you see simplified graphical representations of combined Earth-Moon tilts and inclinations. As we all know, that the sun rises in the east and sets in the west. However, Moon's rise-set points actually vary depending on the Moon phase and season. Moon's rise-set times are not the same every day, it varies throughout the lunar cycle. It's determined by the Moon phase and angle relative to the Sun. Moon lags behind. As you have learned from my earlier video lecture on why the Moon is more and more late every day through Earth's sky, the Moon rises about 50 to 53 minutes later each day, with varying angles with respect to the Sun. Question is, can we watch sunset and moonrise at the same time? Technically yes, in case of full moon, which is at 180 degrees. Well, may not be precisely the same time, but of course within minutes of each other. It varies with the season and the observer's location. Now, in this chapter of the lecture, I present a comprehensive account of how Sun traces its annual path of varying declinations, through seasons, around the globe and the celestial sphere, illustrated with cool graphical plots. Now, in this chapter of the lecture, you are going to see a series of animated illustrations of how Sun's daily journey looks like, east to west, sunrise to sunset, through the sky, above horizon, at specific latitudes, and certain times of the year or season. Moreover, you can see Sun's declination and culmination, depending on the viewer's location or latitudes, illustrated for both northbound and southbound Sun, as well as directly on equator. Seasons are color-coded for conceivable visualization. Equinox conventionally indicates the time or date at which the Sun crosses the celestial equator and shines directly above the equator. It occurs twice each year, when day and night are of approximately equal length all over the Earth. The two equinoxes occur around the 22nd of September and the 20th of March. At full moon in the month of March, near vernal equinox, the two arcs of Moon's path and the Sun's path would be virtually the same. Therefore, at the equinox, the full moon's nighttime path somewhat resembles the Sun's daytime path on that very same day. Solstice conventionally indicates the time or date at which the Sun reaches its maximum or minimum declination, marked by the longest and shortest days, around the 21st of June and the 21st of December. Near the June solstice, during the longest days of the year, the Sun would cross high overhead. And, during the short summer nights, the Moon would travel along a lower arc in Earth's sky, and would spend less time above horizon. Winter moon, cold moon, or long night moon refers to the December full moon that coincides with the longest darkest night of the year, winter solstice, in the northern hemisphere. High culmination, staying visible longer time above horizon, shines brightly through the bleak icy nights. It's thus the longest full moon of the year. directly in contrast. That is to say, in summer in the northern hemisphere, the full moon stays low in Earth's sky through shorter nights, while in winter, the full moon ascends high through longer nights, directly in contrast with the sun's behavior. This path diagram presents a simplified example of a comparison between the full moon's and the sun's pathways in winter in the northern hemisphere. The green line represents the horizon. In the bottom panel, you see the sunrise and sunset points are denoted by red bars with up-down bright yellow arrowheads. The path curve indicates the winter sun spends a very brief period of time above horizon in Earth's sky through the shorter winter days, and stays below horizon through long cold winter nights. Whereas, in the top panel, you can see, the winter full moon somewhat mirrors this pattern. The moonrise and moonset points are denoted by red bars with up-down pearl-white arrowheads. Winter full moon spends a very brief period of time below horizon, through the shorter winter days, and stays above horizon, illuminating the Earth's sky, through the long cold winter nights. We keep saying, full moon rises at sunset directly opposite to the sun. But then again, it makes us wonder, what if the sun sets as late as 10 p.m., or as early as 3 p.m., depending on the local latitude and season? What would happen to the moonrise? Have you ever thought about that? Well, the answer is rather plain and direct. Let's take a random example. Let's say the winter sun sets on the 10th day of the month at 3:30 p.m., and the winter full moon rises roughly around that time, at 3:40 p.m. This full moon will not pass the meridian on that day. The following day, the 11th, it will set at sunrise in the morning, say at around 9 a.m. The rationale behind such contrast or seasonal inversion is, the full moon and the sun are on the opposite sides of the Earth. A full moon occurs when the Earth is between the sun and the moon, when it's at 180 degrees with respect to the sun. That explains why their paths across the Earth's sky are inverted relative to each other. Let's recall the pendulum motion of the sun's annual journey, as you have learned in my earlier video lecture on sun's path. the Sun's apparent path resembles pendulum motion. It passes the midpoint at fast pace, slows down, halts at turnaround points, changes direction, and swings back and forth between the two extremes. Midpoint of the Sun's annual pendulum swing is the equator, the 0-degree declination, whereas the two turnaround points are Sun's northbound and southbound maximum declinations, plus 23.5 degrees up north and minus 23.5 degrees down south. Now, please note that the Moon also has the same type of motion, but much faster and much more perceptible. If you look at the red weeks of the month on the calendar, indicating the Moon spends 2 weeks around one side, traveling half orbit. It spends next 2 weeks around the other side, completing 360 degrees. Yes. Dramatic moon swing. So, as a consequence of moon swing, there are dramatic variations of ranges of northbound and southbound rise points and set points. This you can see in my elaborate geometric illustrations. So, comparison. This means, during major lunar standstill, at its two most extreme points, the Moon appears farther north and farther south in the sky than the Sun ever does at its solstices. The range of the Moon's rise-set points along the horizon during the major lunar standstill is approximately 70 degrees. It's strikingly wider than the Sun's annual range, approximately 47 degrees. Now, resemblance. It makes sense how nearly equal hours of day and night, around the time of equinoxes, can be the underlying logical basis for that the Moon's nighttime journey somewhat resembles the Sun's daytime journey, in terms of rise set points, as well as altitude and duration above horizon.
Ready lecture notes and study materials are available on request. Please use the comment section below for further academic discussions. Viewers' suggestions and ideas of new video lesson topics are gratefully appreciated. Stay tuned for more uploads. Please remember to like, subscribe, share.